All right, so I'm super happy that I see so many faces here. Yes, so my name is Gergo Horanyi. Originally I'm from Hungary. Right now I'm living in Denmark, Copenhagen. I'm working for a company called Founders. It's actually a startup studio. We are in the very early phase bootstrapping a company, doing similar stuff which I'm going to talk today. The name of the talk is Building and Observing Services on Docker Swarm Clusters. The latest and greatest from Docker, inspired by Netflix. So this is going to be a hands-on lab. You can follow everything I do here. Some of you already have this paper which has all the comments, but I will show links which you can follow so you can have all the commands on your browser. If you didn't get the paper, that's fine. We might not finish in time. 90 minutes is not that long. In that case, you can, so like everything is open source, so you can find everything online. You can try it at home. I will still show the end result. Should be interesting anyways. Yeah, just a few words about me. So right now I'm at Founders, but I just recently joined them. Before that, I was working for Prezi, which is this zooming presentation tool. You might notice at some point this presentation is built in Prezi. I was an infrastructure engineer dealing with introducing Docker to the company, going through all the steps, how finding the right spot, how to make sure that we just Dockerize all the services and then we are happy, but giving a bit more than that. Also before that I was doing DevOps at CERN, which is most famous from the Large Hadron Collider. It's in Geneva. I was working on a tool exploring inter-service connections. So basically, what we did there, we just showed which service is talking to what. That's going to be something very similar what we will build at the end of this workshop. Yeah, and mostly that's about me. I love those things, but that's not super interesting. Feel free to reach out to me anytime. That's my email address and my Twitter. Yeah, that's very easy. So this is the agenda. Mostly we'll have two topics, even though there's three here. So we will build a Swarm cluster and deploy something there, so that will be one part. And there will be another part where we do this monitoring observation layer. Yeah. Just as a start, who is familiar with Swarm? Who has used Swarm before, or Kubernetes, or actually any orchestration? Okay, that's pretty cool. So the ones who didn't, Swarm had a huge change. It's not a very fresh project, but it had a huge change in 1.12, which was introduced, I think, late June, I don't know, so recently. So right now this is bundled with Docker Engine, which makes it super simple to set it up. We will see that because we will just do the setup of Swarm cluster. And they've added a bunch of orchestration features, borrowed gladly from Kubernetes and stuff. So if you have used that but not Swarm, it's going to be very, very familiar. And they've added a bunch of more, but that's not really interesting right now. So what Swarm does is, just like in a nutshell, you can bundle Docker engines and look at them as like one logical instance. You don't really care from that point which host runs which container. You just schedule services, you just start services, and then the Swarm will schedule the containers on different hosts. It will take care of all that stuff. You can upgrade services, you can deploy new versions of it. Swarm will take care of all that. I really don't want to go too deep into these things because you can find a lot of things online, and still it is very easy to use and learn. Alright, so I think let's get started with the hands-on part. That's the link I mentioned, so if you just copy that to your browser, you could get the very same paper as here. At least you can copy-paste instead of typing, as you prefer. So that's about deploying our application. So this is what we have there. That's what's running there. We've seen that this is working. We have multiple instances of the voting up. That's wonderful. There is one slight problem though. If you start to adapt all the Docker infrastructure and all the orchestration frameworks on top of it, you will find yourself in a situation where all your infrastructure is really flexible, it's really dynamic. Everything changes very quickly. it's very hard to follow what happens. If you have a big enough engineering team, and I'm not talking about the Google size or Netflix size, but if you have like at least 2-3 engineering teams working independently, you just don't have the chance to understand the entire system because it will change very rapidly, because it is super easy to define new systems, right? We just done it, new services. It's super easy, you can do it, and even there is like a lot of automation behind. You just won't understand everything for sure. So you need good tools to observe, to monitor what's happening. There are like a plethora of tools out there in the market which tries to do that. There are better ones, worse ones. I just like select a few, but like completely randomly. You can host it on your own. You can just buy something third party. Some of them are super expensive. Some of them are really cheap. But like none of them really solves one problem, I think, at least. That you will, since you have a lot of things running, you have a lot of small, very small containers, you will have a shitload of metrics. You will have thousands or 100,000s of metrics. You will have a lot of data coming in, and you just can't keep up with that. You cannot just define alerts for everything. You cannot keep an eye on always everything. You cannot have people who just sit there and always scroll through data, what's happening. It's not an option that if your system fails, if your service is down, your customers are like pinging you on Twitter that something is broken, you cannot just go through all the dashboards you have to understand what happened exactly. Of course, there are some AI solutions on the market which say that they will like pinpoint it, they will find everything all of a sudden. I don't have very good experience with those. I don't think that right now we are at the state where there could be just one AI algorithm which finds the root cause of a problem. So that, I think, doesn't work. On the other hand, what could work, but of course there are solutions for this. There are large companies who faced this issue like years ago. Google, Netflix, they have huge infrastructures. They must have solved this somehow. And even though if you don't have that big infrastructure with all these small containers, you will end up with, of course, not the same complexity, but you are getting closer to their problem. So what we did is we looked into how Netflix does this. They've built this tool. First it was called Flux. Now it's called Visceral. This is a very simple UI, open source. You can just download it. So this is what they use for themselves. So what you can see here is this is the 3 regions where they operate. And they have, something is wrong with US West 2. They have warnings. And then all of a sudden, they start to react on this. They start to send data to the other regions. First, they start to proxy it. Then at a point, you'll see how they switch DNS and just send everything directly there. But that's not really interesting. What is interesting, though, is that just by looking at this very simple graph, you can understand all that. You don't know how things are implemented. You don't know what exactly is happening behind. But still, if you have the basic understanding of network, like you have an idea what services you have, you will understand what exactly is happening. Now you see that like everything is going directly there. You know that you don't send basically traffic there. There's only a few dots going there. So this is very easy to digest. You can just use your engineering intuition to understand what is happening. They call this, by the way, intuition engineering exactly for that reason. And now you can see how when the problems are solved, they just direct everything back. Of course, usually, I guess it doesn't take them 90 seconds, but a bit more. It's just a video. Anyway, so I think this is pretty cool. If we all could have something, such simple way of showing stuff, I'm not saying that you could like understand all your problems from this. This is not a tool to replace Neuralink or Datadog or whatever you have. But this is a tool which might give you a hint where to look, where to dig deeper. And as it turned out, this is super easy to set this up for a Docker Swarm cluster. And we did this for Swarm, and we will now do that together. But you can actually just, so like we just took Swarm because that was at hand, so you could do this with any clustering solution. So I'm just So what is going to happen right now, I will just show you how we did this, and I just encourage you to do the same if you think this makes sense. Of course, like you can choose different implementations, but the idea is very simple. You should have a very high-level abstraction on what's happening. With the help of Docker, so Docker is cool because you can just take one container as a black box. You don't even have to care about what's inside, and you can just start adding stuff around it and see what's happening. So you don't really need to build something application specific. You can just build stuff around a container. All right. So what we did is very simple. There is a tool called Packetbeat. Anyone here aware of that tool? Cool. That's awesome. So Packetbeat was written by 2 people, a couple actually, I think. But Elastic acquired them. Elastic is the company behind Elasticsearch. So now there is this thing called Beats in Elastic, which is for lightweight data transfer to Elasticsearch. And Packetbeat is one of those beats. The point of this tool is that it sits on your network interfaces and analyzes the traffic. So basically what happens is, in a simple way, it does a TCP dump and recomposes HTTP SQL and Redis requests. That's very simple. So it basically converts layer 4 stuff to higher level stuff. And then it sends everything to an Elasticsearch. So for each transaction you have a request and a response, you will have one document in Elasticsearch. The good thing of Packetbeat that this is completely independent from your language you use to program, because if you're using these protocols, it's going to be fine. They support a bunch of other protocols, and this is open source, so you can very easily just add yours as well. But basically, without any deep configuration, right out of the box, you can get these things running in like less than 5 minutes. So what you can do is you just run this Packetbeat next to your container, and then you actually get a lot of things out of the box. So what we did is we wrote a small agent. The only purpose of that agent is that you start it on the host, and then it will collect some information about the running containers and services, and also it will start the Packetbeat instance and configure it properly. We have this agent. This is not a product you can buy. I'm not trying to sell you this thing. I'm just trying to show you that this is very simple. And exactly for that reason, this agent is open source. It's just a very small prototype to just look it through, try it out on your own, write a better one, fix it. It's just a test that this is possible to do and very simple. So what happens here is the agent sends us which containers are running, what are the IPs for the network interfaces. And then it also starts Packetbeat. With Docker, what you can do is that you can clone network interfaces. So you can say that the Packetbeat container has the same network interface as the running container. So that way, actually, Packetbeat can intercept all the requests, all the TCP data going to and from the container. And it does it in a way that it doesn't sit between your container, your service, and the network, but it sits next to it. So for example, while Neuralink runs an agent in your runtime, this one sits just next to it. And the point of that is that if the agent goes crazy, it can kill. So if a Neuralink agent would go crazy, it could kill your service, right? It runs in the runtime, it can do whatever it wants. This Packetbeat thingy, it just runs next to it, so if it goes crazy, the worst thing what can happen is CPU and memory. Of course, this is not a perfect solution. The biggest problem is that it's CPU and memory, because it takes CPU time to convert from TCP to HTTP, so this can go up a lot. There is a lot of things to work more on this. Of course, if you already have access logs or something like that, and that's how, of course, Netflix does it. They don't run TCP dump next to their production services, but they just use their access logs and pick data out of it. So there is a lot to optimize on this, but this is a good start. You can take a look on a lot of things. So what we did, just for this demo's sake, we packaged everything on the right side into this Docker Intuition backend, which we can download. and then we start that on our swarm, then we start the agent, and then we'll see what we get. All right, let's do that. So I'm still on the manager. So what I'm going to do is I will start the backend. This is a very bluntly created container. I think it's like 800 megs. Sorry about that. But so I will name it Wisdemo backend. Let's expose 8080 ports. That's where the Visceral runs. Let's expose this port. This is where there is a Python, a Django app running in it, which stores the container and service informations. So the agent is talking to the backend through that port. And let's also expose this one. This is not really important, but anyways, this is the Elasticsearch running in it. If I attach to the workshop network we've just created, and then I will just download the Docker intuition backend. Oops, what did I forget? Of course, Docker service create. There you go. Okay, so it will take some time to download. So from that point we will have the backend. So we will have an Elasticsearch, we will have this Django app running, and we will also have this Visceral thingy there. So Visceral is that graph UI created by Netflix. Alright, so the other thing we need to do, we need to run an agent on all our nodes. So this is a bit different, right? Because this time we don't know how many replicas we need, we just know that we need one instance of that running on all the nodes. Of course, there is a solution, a very simple solution for that. You can define global services. So what we need to do, Docker service create, let's name it Docker agent. I will need to mount the Docker socket. For the reason is that the agent itself will create new containers, so it will start the packet beat, and for that it needs to access the Docker engine. So what I'm gonna do is mount where the source is /var/run docker.sock. Target is the same, so I will just mount this, and from that point the container itself can actually execute Docker commands from inside the container. So this is where I tell Docker that this should be a global service, which means that I need exactly one instance of the container running on each and every node we have. Then the standard part where we say that it should be attached to the workshop network. And yeah, Docker agent. There we go. Cool. So Docker service OS. What do we have here? Almost. So we have everything defined. The Wisdemo backend is still not running for me, and I guess that's the same for you. As I said, it's a huge container. Yeah, we could have optimized that a bit more. Sorry about that. But in like a couple of seconds, it should be up and running. And when that happens, so when that happens, then Docker agent will start to communicate with the backend. It will start to inspect what containers, what services are running. It will collect information on the network interfaces, so it will send all the IP addresses of each container to the backend, and it will also start packet beats. Yes, it's there. So now it's running. Alright, so then that means that, so as I said, it should run packet beats, so we should see that, right? So if I say Docker PS, I know it's a bit hard to see. Yeah, I don't see them yet. Give me a sec. Okay, it should. Yep, okay, it just took some time to react. So what we see that right now, we just very bluntly fire up packet-beat containers to observe all the running containers here. So if you have 5 containers, all of a sudden you will have 10. Of course, this is like suboptimal at least. But this is just to give you a hint that this is like possible to do. Okay, so when that's done, that means that the packet beat will collect TCP stuff and send to the backend. So if I would do any voting right now, so I'm just generating some traffic to be able to see what happens. If I open the result, yep, 700 votes. Wow, guys, you're active. Okay, so let's just. What's my IP? So let's just open Visceral. It takes some time to load for the first time, so give a few seconds to this. Let's just move on this. So this is what we have, like without any configuration. This would work for any services. We didn't like burn this layout in. This is coming only from the real traffic. So this is completely real-time stuff. What you have there, you have internet. You will see that there is a little bit of traffic going to the voting front end, which sends stuff to the Redis. We see that the worker is like super crazy. It polls the Redis. It's a very stupid implementation. You see it right out of the box that there is something wrong with the worker. It shouldn't send so many requests to the Redis, but that's how it's done. Then the worker, when there is a change, it sends a Postgres request to the database. We see that there are sometimes red dots. That's happening because there is actually a Postgres error in some cases. Also, like this is super crazy implementation. If you would like, you could very easily fix it, but that's not the point. And then also there is the result. Also, what we get from that it polls the database insanely, and then also it updates the internet. So like your browser actually continuously polls the result front end if there is a change. So that's why I didn't need to refresh when you voted and it moves still. So all that we can just get from just a peek of this without really going into details. You don't have to go through what happens, like how do they communicate, what exactly they talk about, like. But all of a sudden you understand a lot of things very easily just by looking on this view. You can see if there is a change in the traffic. You can see if something is unusual. That's something which is very hard to do with AI stuff. Of course, there are solutions for that. There are solutions for finding anomalies, but they are, at least my experience is that they are very far from what your brain can do. Is that you just, if you have an issue, you just look on this, and all of a sudden you will see that yes, that's strange, or you have like too many errors going through there. And of course, you could have like alerts for all the edges. You could have like dashboards for everything, but just imagine like you would need one graph, one chart for each and every connection, and like even for this very simple application, you would have already quite a few. So what I'm saying here is that there are very good tools already open source which you can use very easily without going into deep understanding all the deep levels of Docker. Without knowing too much of this, you can still just build something very simple which can be used to understand what is happening. Just imagine when, like, I guess it happens that you have a new engineer coming into your team and you sit down and you explain the entire infrastructure. You need to find a documentation which shows your architecture. Just think about, I'm 100% sure that architecture diagram you used last time, it was outdated. This thingy is real time. Without any configuration, you will always get a real-time look on what's happening, what is the current flow in your system. I think this is pretty awesome. And I can only encourage you to build something like this at your organization because it will make your life better, I think. And yeah, with that, I will say thanks a lot. I know that we still have time, so please feel free to ask any questions. If you got stuck somewhere, I'm happy to fix it for you, go around. Also, we wrote a blog post about this. You can find it there. It's with a bit more context and details. This is again, this is not a product we are selling, but we think there is a great potential in this, and we encourage everybody to build stuff like that. Yeah, so just go for it. And if you feel like reaching out to me anytime, just do it on Twitter or in my email. Thanks a lot for your attention.